If the charges they have given, either cation or anion, if the anion charges they have given, then how to identify the hybridization? Which iodine will form the single bond? Now this is S, now this is P. Now remaining all are the lone pair of electrons. Now this is P. Clear, my dear friends? I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. Now in this video we are going to see now within fraction of seconds or within less than 30 seconds how to identify the hybridization of the given molecule and number of lone pairs on the central atom. Now here is a one very interesting trick I was going to explain. Now let's start our video. Yes, before going to start the trick, now you have to remember the valency electrons of the atoms or that group of the atoms. Now we'll see first the carbon valency electrons are 4, then nitrogen valency electrons are 5. Next we are having the oxygen valency electrons are 6, and the next we are having the fluorine valency electrons are 7. Fluorine valency electrons are 7, and the carbon group 4, nitrogen group 4, nitrogen group 5, oxygen group how many? 6, and the fluorine group 7. Next, and the next very interesting point you have to remember that hydrogen to complete its octet it will form only single bond. Now oxygen to complete its octet and nitrogen to complete its octet it will form triple bond. Clear? Now next, fluorine to complete its octet it will form the single bond. Done? Now let's start our trick with the question. First of all, if you want to find the hybridization and the number of lone pairs on the central atom, first trick is atom which is in higher size the central atom. First identify the central atoms in the given molecule. Then after that what you do, write the valency electrons of that central atom. Xenon will comes under the 0 group. Now its valency electrons are 8. So 1, 2, 3, 4, 5, 6, 7, 8. Done? Now each fluorine will form the single bond. Done? Now each fluorine to complete its octet it will take the 1 electrons. Clear? Xenon is having the 8 valency electron. Now it has taken the 1 electron. Now the fluorine octet has been completed. So this is S. Now this is P. Now remaining electrons which has not participated in the bonding, those we call it as a lone pair. One lone pair contains 2 electrons, right? Clear? Now one lone pair contains 2 electrons and this is also P. Now another lone pair contains P. Clear? Now another lone pair, now it will be the D. Clear? Now what is the hybridization of the XeF2? That is sp3 D with how many lone pair? With a 3 lone pair. Simple. In this manner we have to identify. Now next we will see the XeF4 they have given, right? XeF4. Now right, valency electrons of the xenon are 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now fluorine will form the single bond. 1 fluorine, 1 fluorine, 1 fluorine and 1 fluorine. Now this is S. Now this is P. Now this is P. Now this is P. Done? Now here the 4 electrons has not participated in the bonding. That electrons which has not participated in the bonding we call it as a lone pair of electrons. Clear? Now this xenon we call it as, this is D and this is D. Clear? Now what is the hybridization of the XeF4? sp3 D2 with a how many lone pair? With a 2 lone pair. Clear? And the next we are having PCl3. Clear? Now the next we are having the PCl3, right? Now phosphorus is the central atom. Now write the valency electrons of phosphorus. Now valency electrons of the phosphorus are 5. 1, 2, 3, 4 and 5. Now chlorine will comes under the fluorine family. Now to complete it octet, 1 electron it is required. So 3 chlorines are there. So 3 chlorines will take the 3 electrons. Done. Now this is S. Now this is P. Now this is P. Now unbonded electrons are which has not participated in the bonding, that is called as a lone pair of electrons. One lone pair contain 2 electrons. Now this is also P. Total. Now what is the hybridization of this one? This is sp3 with a 1 lone pair. sp3 with a 1 lone pair. Clear? Now we'll see the remaining questions. Now here they have given the SF6. Now here the fluorine and the sulfur, which is higher in size? Sulfur is a higher in size. So the sulfur is a central atom. Now sulfur contain how many valence electrons? Sulfur contain 6 valence electrons. Now write 1, 2, 3, 4, 5, 6. Done. Now fluorine. Each fluorine will form the single bond, or it will take the 1 electrons from the sulfur. Clear? Now here this is S, this is P, this is P, this is P, this is D, this is D. So what is the hybridization of the SF6? sp3 D2. sp3 D2. Now comes to the IF3. Now iodine will comes under the fluorine family. Now iodine valence electrons are 7. 1, 2, 3, 4, 5, 6, 7. Now each fluorine will form the single bond. Now 1 fluorine and 1 fluorine. Done. Now this is S. Now this is P. Now this is P. Now 2 valency electrons. Now 4 valency electrons has not participated in the bonding, that we called as a lone pairs. So 2 lone pairs. Now what is the hybridization of IF3? sp3d with how many lone pair? 2 lone pair. Now next comes to the IF5. Now valence electrons are 7, right? 1, 2, 3, 4, 5, 6, 7. Now 5 fluorines, 1, 2, 3, 4, 5. Here the 5 fluorines we are having. Now this is S, this is P, this is P, this is P, this is D, and this is D. Clear? What is the hybridization of this one? sp3 D2 with how many lone pair? With a 1 lone pair. With a 1 lone pair. Clear? Now, if the charges they have given, either cation or anion, if the anion charges they have given, then how to identify the hybridization? If the anion charges if they have given, first identify the central atom. Carbon is a central atom. Now carbon valence electrons are 4, 1, 2, 3, 4. Now -2 charge. This -2 charge indicates that electron added or electron removed? Electron added. How many electron added? 2 electron added. Clear? Now the 2 electron are added to the valence electron. Now already I explained you very clearly. Oxygen will form the double bond, means it will take the 2 electrons from the central atom. So one oxygen will take the 2 electrons from the central atom. So one oxygen will take the 2 electrons from the central atom. One oxygen will take the 2 electrons from the central atom. Clear? Now this is S. Now this is P. Now this is P. Now what is the hybridization of this one? sp2. sp2. Simple. Now comes to the phosphorus case. Phosphorus valency electrons are how many? 5. 1, 2, 3, 4, 5. But here the -3 indicates that it has taken the 3 electrons. Total 1, 2, 3. Total 8 electrons. So each oxygen will form the, or each oxygen will take the 2 electrons. Now each oxygen will take the 2 electrons. Each oxygen will take the 2 electrons. Each oxygen will take the 2 electrons. Now here it is S. Now here it is P. Now here it is P. Now here it is P. Total hybridization will be sp3. sp3. Now comes to the ClO3 minus. Now 1 chlorine having the valence electrons are 1, 2, 3, 4, 5, 6, 7, and negative indicates that 1 electron has added. Total 8. Total how many oxygens are we having? 3. So 1 oxygen will take the 2 electrons. Now total 3 oxygen, and the remaining is a lone pair of electron. It has not participated in the bonding. So this is S. Now this is P. Now this is P. Now this is P. Clear? Now this one will be the sp3 with one lone pair. sp3 with one lone pair. Done? Now, if suppose cations are given. Now cation indicates that loss of electron or gain of electron. Loss of electron. Now one nitrogen contain how many valence electron? 1, 2, 3, 4, 5. Now positive charge indicates that one electron has been lost, that total 4 electrons only. Now one hydrogen will form the single bond. So 4 hydrogens we are having. 4 hydrogens we are having 4 single bonds. Now this is S. Now this is P. Now this is P and this is P. Clear? What is the hybridization of this one? sp3 with a 0 lone pair. 0 lone pair. Now comes to the which one? H3O plus. Compared to the H3O plus, oxygen is a central atom here. Now oxygen central atom, normally oxygen contain how many valence electrons? 6 valence electrons. 1, 2, 3, 4, 5, 6. Clear? Now in this 6 valency electron, now 1 valency electron has been lost from the oxygen. Total only 5. Now how many hydrogens we are having? 3 hydrogens we are having and 1 lone pair. So S, P and here it is P and here it is P. So this is sp3 with 1 lone pair. And you may got a doubt here that sir, why not the hydrogen will form the, or why not the hydrogen will act as a central atom? Now you see, this any atom to act as a central atom, it should form the 2 bonds. It should form the 2 bonds. But hydrogen, by taking the 1 electron itself, its octet is completing. That's the reason hydrogen does not have any electrons to provide the double bond. That's the reason hydrogen will never and ever will act as a central atom. And fluorine also, by taking the 1 electron, its octet is completing. So fluorine also will never and ever will act as a central atom. Remember these two. Next I3 minus and I3 plus. I3 minus and I3 plus if they have given, normally iodine valency electrons are how many? Here 3 iodines are there. So how to identify? So among the 3 iodines, you take 1 iodine as a central atom. Among the 3 iodines, what you have to take? 1 iodine, you have to take it as a central atom. 1 iodine contain how many valence electron? How many? 7 valence electron. Negative indicates that 1 extra electron added, right? Total 8 valency electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Done? Now each iodine will form the single bond. So among the 3 iodines, 1 iodine has been formed the central atom. 1 iodine is acting as a central atom and the remaining 2 will acting as a bonded, right? So each iodine will form the single bond. Now this is S. Now this is P. Now remaining all are the lone pair of electrons. Now this is P. Now this is P. Now this is D. Now I3 minus, what is the hybridization? sp3 D with how many lone pair? With 3 lone pair. With 3 lone pair. Done. Next I3 plus. I3 plus. I3 plus valency electrons are 1, 2, 3, 4, 5, 6, 7. Now what I said, 1 iodine you take it as a central atom and remaining 2 will be bonded. Among the 7, 1 electron has lost, right? So 1 electron has been lost. Only 6 valency will be there for the central iodine. Then remaining 2 will be act as a bonding. Now this is S, this is P and remaining this is P and this is P. Now what is the hybridization of this one? sp3 with a 2 lone pair. With a 2 lone pair. Clear? Now this is the simple trick to identify the number of lone pair of electrons on the central atom and the hybridization. Clear? Now next we will see with the other trick in the next video.